rates. So they are rates that have a relationship, honestly, like that's it. They're rates that go together, just like you and your brother or sister go together. You're part of the same family, right? These rates are related somewhere. We're going to be working on how to relate. So here we go. I have a very definite process, very definite idea for how to attack a word question, albeit this one's pretty darn short, right? It's 2 sentences. But we have a definite way of attacking these. Can you imagine the panic you might feel if all of a sudden this question was 6 sentences long with a picture? Might you feel differently? We'll get to those, don't worry, we will. And so the system I want to show you here is, I think, a really great way to help you tackle any word problem. Have you ever looked at a story problem and just thought, I don't even know where to start? I'm stuck. So I want to help you with that, okay? I want to give you some very definitive ideas on how to get unstuck. So number 1, here's what we do. Just read it as a story. Don't freak out about units or math or variables or what the answer is yet. Just read it like a story. Ready, set, go. Can you summarize what this story is about? Somebody summarize what's happening here. Oh, tick tock, tick tock. Please say something. There's no wrong answer here, really. Yes, sir.
Some expanding cubes.
There's a cube, not cubes. I think it's just 1 cube. And it's expanding. Yes, it's getting larger. That's it. That's the whole summary of the story, right? Okay. It might seem really stupid here because it's 2 sentences and you could just tell it pretty quickly. But again, what if it was 6 sentences long? It might be a little harder to do, right? So there's a cube and it's expanding. So next idea, we want to know what we're supposed to do. So we want to identify what we're being asked to find. And what we're going to do is we're going to mark the question up. We're going to actually put a box around what we're supposed to do, what we're supposed to find. So take a second and try that. Draw a box, like literally take your pencil and draw a box around what we're supposed to find. Okay, did you put the box around the same thing I did? I'm going to split my box up there a little bit, but okay, so we're trying to avoid that situation where you stare at this word question and the story problem, you just think, I have no idea what to do. I'm stuck. It's words, it's a math class. We put a box around the stuff we're supposed to find. And here's what we're going to start doing a little bit of now. We're going to take this phrase here, how fast is the volume changing? And we're going to try to take it and interpret it into one of those Leibniz rate variables like you just did in the last couple of minutes. So please do this as quickly as you can. If you know the answer, just say it. Even if you think it might be wrong, get the ball rolling here. How fast is the volume changing? Interprets as? Say again? There you go. dV dt. Is that not the rate of change of volume with respect to time? That's perfect. Sweet. Okay. This is our unknown. This is the thing we're going to try to find in the end. So I just put a couple of question marks there signifying that's what I'm trying to get. Once I have this, I'm done. So the next idea is, remember, these are related rates. These are rates that have a relationship. There might be more than one rate. I mean, that's one of them. The thing in red up there, that's one of the rates. But do you see any other rates? If you do, we're going to underline that. You see any other rates happening in this scenario? Eli?
Expanding at a rate of 6 centimeters per minute.
Yeah, the edges are expanding at a rate of 6 centimeters per minute. So Eli, what are some words that told you, hey, this might be a rate?
It says at a rate.
Yeah, the word rate was right there. I mean, how many times have you been faced with a question like that and you're just like, I don't know. I feel lost. I'm frozen. But if you really take the time to underline stuff and put a box around something, doesn't it force you to actually look at the words? Have you ever, now, I'm not going to tell your English teacher, but in an English class or history class or whatever, have you ever had a reading assignment and you get to the bottom of a page of the reading assignment and you think, I have no idea what I just read? like your eyes moved over all the ink on the paper, but you weren't actually engaged in your reading, and you're like, I gotta go back to the start and read that page again, right? So when you mark the question up, it forces you to say, hey, what does that word mean? Is that word important? Eli said, hey, it says rate. Did you notice that the units are in agreement with what Eli said as well? It says centimeters per minute. Isn't that a lovely rate unit? Centimeters per minute? Okay, cool. So we're going to interpret this just like we did with the dVdt. How would you interpret this? The edges are expanding at a rate of 6 centimeters per minute. What kind of a Leibniz variable could you use there? Okay, don't be quiet, just be quiet. If you think you got something, let me know. Be right, be wrong, just be loud. Go ahead, Kaylee.
DAGT
Why did you use the letter A?
for area, because it's like the edges of it, I guess, and
So I think I need to define something here. Here's my 5th grade cube. Practiced my whole 5th grade year for that. Isn't this length? Isn't it, when we say edge, isn't that what we're referring to? Isn't it the length of like the wire framework of the cube? So I love your D something DT, but I don't know if I'm in love with the A because I don't think there's any area involved, at least in our particular scenario. Does it make sense? So let's piggyback off that. She said DA DT. Let's make it D something else DT. What do you think it could be? L standing for length. Could you also use E?
Yeah.
E for edge. I'm going to go with L because Cooper said it first, but we could go with E as well. I'm going to say DL DT equals what? It's 6, right? I mean, it tells you right there, the rate of change of the edges is 6 centimeters per minute. So the last thing we need to do to pick out of this question, the important stuff is what I like to call the freeze frame moment. That would be like if we were watching a movie and you needed more popcorn to go to the bathroom or something, you would pause the movie, right? You'd freeze frame the movie. Yes? So we're going to put a circle around this freeze frame moment. What do you think that freeze frame moment is?
2 centimeters.
What's the word that tells you that that's the freeze frame moment? When is a key word, right? Yeah, so I'm going to circle this. That is definitely the freeze frame moment. So it's when L is 2, since we're using L to stand for the length of the edge. L is 2 centimeters. Okay. So we're going to finish this one up here. Remember, these are called related rates. I'm a little bit nervous here because of our tendency towards silence. I'm going to ask you to make a big connection. It kind of hangs on this connection. Over there on the left, we wrote down dV dt and dL dt and L, 2 centimeters. What mathematical relationship connects those things together? We got a cube, we got a V, we have length of an edge. What's the mathematical relationship that connects those together? So certainly time moving forward, the V and the L are changing, but I'm looking for, when I say, and by the way, when I say relationship, a relationship in math is usually an equation or an inequality, right? Where something equals something else or something is greater than something else. So time is a connecting factor, no doubt. What I'm looking for is more of an equation that relates the V, in fact, we have a cube, the V, and the L. Say louder. Even louder so even Danny can hear you. Isn't that the volume formula for a cube? Volume equals the edge length cubed. She's right. Volume equals L cubed. That relates those things together. It says the V is related to the L in such a way that volume is equal to the L times L times L, L cubed. That's how you find the volume of the cube, right? Okay. So this is kind of like picking out our movie here, like we watched the water in the glass freeze. We've kind of picked out our movie here. The way that I push play, the way that I get this going is I got to realize I need derivatives, don't I? Don't I need dv dt? Don't I need dl dt? I mean, so Ellie's idea about v equals L cubed is right on the money, but we need to actually push play and get this thing moving. We got to get the cube expanding. So how do I get a bunch of ddt's involved here?
Did you just take the derivative of it?
With respect to
Time.
time, t. That's right. That's what we're going to do. So I'm going to write ddt of both sides. On the left side, ddt of v. What's ddt of v?
dv over dt.
So it is dv over dt, and you said, oh, I thought somebody else said, I must have.
1.
So this is an implicit differentiation scenario. And I'll write this and I'll erase it. If I had ddv of v, the answer is just 1, right? But I have ddt of v. So wouldn't there be a chain rule factor? Just like implicit differentiation. And so that's why we'd probably just say dv dt. Technically it's 1 dv dt, but I'll just write dv dt. The right side is a little more complicated. It's ddt of L cubed. So any thoughts on what ddt of L cubed would be? Go ahead, Carter.
6L squared VL dt.
6, where are you getting 6 from?
Or 3L squared.
Okay, I like that. Power rule, right? 3L squared, but remember we're doing ddt of an L?
Yeah, so it sounds good.
So the chain rule factor is dl dt. You see how we're almost done now? All that work we did at the start, picking this question apart, has made this finish very easy because the thing I'm looking for, there it is. dv dt, that's what I was looking for in the beginning, right? And I look on the rest of it, well, L, oh, that's my freeze frame moment, right? I just need to plug in my freeze frame moment. DL, oh, I have DL dt because I wrote that down because I picked the question apart at the start. I got all the pieces that I need. I just need to drop them into the appropriate place and I'm done. So we'll say dv dt equals 3 times 2 squared times 6. All that work on the front end should make the finish pretty easy in most cases. So as long as I can do a little arithmetic, I'm in good shape. 3 times 4 times 6 is 12 times 6, which is 72. My final comment would be, final question would be, what units would go with this?
Centimeters per minute.
Close.
Centimeters squared.
She said centimeters per minute. How should we change this?
Centimeters squared.
Not squared, because centimeters squared would be what concept? Centimeters squared? No,
Centimeters cubed.
it's area. So somebody said centimeters squared is area. What goes?
Cubed per minute.
Hey, there we go. Is it cubic centimeters volume unit? The masks aren't doing you guys any favors. What I just heard was, and it's not your fault. It's, you're all talking to the masks. Okay, so this is only day 1. We have 3 more days. We're going to practice these. So if you look at this, you're like, whoa, it's a little scary. I'm not expecting you to have this building downstairs right this second.